Hello, Algebra 1 students. Today we're going to be looking at activity 522, and this is going to be a follow-up to the posters that you made. If you look around the room, there are several posters hung up, and that's what you did right before we did the Y-top. And so from the posters, remember what we talked about is there's big families of functions called linear and exponential. Please write this on your paper because you're going to need to know these big families. Okay, so we have linear and exponential. Each family has, what we were talking about, the nuclear family, the main parts of the family, but we also have extended family. And in linear, we have this thing called arithmetic sequences. Now, arithmetic sequences make a line, but they are discrete. We don't connect the dots. They're like our bouncy ball and rabbit problems. Exponential is our geometric sequences, okay? And those create the things like, linear is not our bouncy balls. Those are like the bike problem and the down on the farm problem. Exponential is our rabbit problems and our bouncy ball problems. So that's what we were looking at last time when you made your posters. How did we create arithmetic and how did we create geometric? So you were given a list of numbers like -9, -5, -1, 3, 7, and asked to find the next 2 or 3 in that sequence. And so this one, what you're trying to do is you're trying to figure out what are you doing to get from one number to the next, and you are adding 4. So if I add 4 to 7, I get 11. 11 plus 4 is 15. Because I'm adding the same number over and over and over again, that makes this, okay, arithmetic. Arithmetic is when you're adding and subtracting the same number over and over again. Now, this is something that you are familiar with, but we haven't discussed it with sequences, and that's the zero term. Remember, anytime you are given a list of numbers, the very first number in the sequence represents the first term. So you have to take a step backwards to get to the zero term, which means you're subtracting 4. Okay, so -9 minus 4, that would give us 13, -13. All right, remember our SG represents our sequence generator, and that is, how are we building this? Well, our sequence generator is we are adding 4. Now, because we know this lives in the world of linear, we're adding the same number over and over again, we know that our equation looks like this. Y equals mx plus b. So we write y equals m is our sequence generator. Oh, and our zero term represents our starting point, or that, that represents that starting point, or our y-intercept. Now, here's where things are going to get complicated in Algebra 1. Because we are living in this world of sequences, the extended family of linear, we no longer say y and x are our variables. To denote that we have a sequence, we use this thing, okay, called T of n. And it looks like that. And I'm going to write it weird. It's going to look weird, but T of n equals the slope times n plus b. Okay, so T of n is like our y. It's a fancy y. SG is the slope, or our sequence generator, but instead of using x, we use n, and we have -13. So that is what our sequence or our equation is going to look like, and that's what you're going to be doing today. Can you write the equation of these sequences? Now notice, please, that this is okay. It still looks like y equals mx plus b, so for a while, if you put y equals mx plus b, it's okay. We just want you to get used to that. T of n equals 4n minus 13. Okay, next sequence, we're at 7, 14, 28, 56. You can see quickly that these numbers are getting larger fast. We're not adding the same number, so when you see that, think about multiplying. So 7 times 2 gives me 14, times 2 times 2. That means if I take 56 times 2, I get 112. If I take 112 times 2, I get 224. Because I am multiplying by the same number over and over and over again, that means it's geometric. Now, just like before, you have to find the zero term or the starting term, okay? but you have to go backwards. So that means we are going to be dividing by 2. So 7 divided by 2 is 3.5. The sequence generator is multiplication. Now, for you guys, you've never written the equation of an exponential. And so if we are just living in the world of exponential, this is what it looks like. Y equals AB to the x power. Now, what makes exponential unique is that the variable is in the exponential place. But be careful, the y and the b means something different than y equals mx plus b. In this case, y equals a, that represents our friend, the 0 term, and b represents what are you always multiplying by? Because that's what's being raised to the power, the exponent. I'm always multiplying by 2, so I'm taking 2 times 2 times 2 to generate this, which means that x and that 2 have to belong together. That's how you write the exponential. Plug it in and try it. Okay, everybody plug in 5 for x here in your calculators. Take 3.5 times 2 to the 5th power and see what you get. You should get 112, okay? Try it and see. Okay, but again, because we're living in the world of sequences, this is going to be our starting point. I'm going to write this out in words a little bit. Times the sequence generator raised to the n power. So we have to use our t of n and n's here. I'm going to scoot that over so you guys can see it. So t of n is the starting point, which is 3.5. Our sequence generator is 2, and instead of x, we use the variable n. That just represents that we have a discrete or a sequence for our functions. You guys are going to get used to this. Don't worry, remember, the first day is always the hardest day. You'll get used to it. Okay, but because this is Algebra 1, you know that things are always going to be presented in different ways. You're not always going to get a sequence that has just a list of numbers. Sometimes your sequences are represented in tables, but the information that you need is exactly the same thing. It's just that now things look a little different. Okay, so I look at this and I say, okay, so 2793. Clearly I'm not subtracting by the same number over and over and over again. Okay, so what do I have to do? Well, I have to think about what am I dividing by. So 27 divided by 3 gives me 9. 9 divided by 3 gives me 3, but be careful here. Remember when we did our posters, it's not about what you're dividing by, it's by what you're multiplying by. So if you're dividing by 3, you're multiplying by what fraction, really? Okay, and so we're multiplying by 1/3. And that's what you need to understand, is that's how we work this, okay? So if I'm dividing by 3 here, how am I going to get my 0 term? Well, I have to go backwards. So what's 27 times 3? I got to go backwards, multiply by 3, and that'll give me 81. So because I'm multiplying by 1/3 over and over and over again, this is a geometric sequence. My 0 term is 81. My sequence generator is multiplying by 1/3. Okay. All right, that means my equation. I start off with t of n. I start with my starting point of 81. I plug in 1/3 as my sequence generator, and I raise it to the n power. And that is my formula. So put in 3, okay? Put in 3 for n, put it right here, okay? And see if you get 3, all right? Take 1/3 to the 3rd power, multiply by 81, you should get 3, because the 3rd term in the sequence is 3. All right, I'd like you to pause the video here, and I'd like you to try this next table. I want you to fill out the 0 term, circle if it's arithmetic or geometric, find all the pieces and see if you can write the equation. Okay, all right, pause the video here and see what you get. All right, welcome back, Algebra 1. I want you to check your answers. You should have noticed that this is an arithmetic sequence because you're always subtracting 3. You have to work backwards to get your 0 term. And then your equation is just y equals mx plus b, or t of n equals the slope, which is just the sequence generator, negative 3n, and then plus your zero term. Okay, flip your page over, because again, the way the sequence is presented can look different. The information you need is exactly the same. It's just now you have a sequence represented as a graph. Now, these graphs are discrete because they are sequences. We don't connect the dots. And so you'll see you have all of this graph with a bunch of points. All right, but how does this work? Well, you know what I'm going to tell you guys is, if you don't like the way the sequence is presented, put it in a format that makes sense to you. And having taught this for a while, I noticed that students do really well when things are presented in a table format. For some reason, that format really helps students see the pattern. So let's put it in, and instead of x or y, now if you put x or y here, it's okay, because that's what n and t of n mean. It's just our fancy mathematical way of saying, oh, we have a sequence. Now let's put in our terms. So the zero term is negative 3. Our first term is negative 1. Our second term is 1, and our third term is 3. Okay, so now we start with, what is this? I like the table format because I can see if I'm at negative 3 and I go to negative 1, I go to 1, that's a pretty consistent pattern. I'm probably adding something, and I'm adding 2. So that means it's arithmetic. And the nice thing about this is they gave us the zero term. I don't even have to work backwards to get that thing. And my SG, or my sequence generator, is plus 2. So my equation is T of n equals 2n minus 3. All right, and I'm going to raise that up just a little bit so you can see that. Okay, again, I want you to pause the video here. I want you to see if you can figure out the second graph, see if you can write the equation or set up the table, and then find those first 3 things. And if you're still a little confused about the equation, wait for the class to reconjoin. So pause the video here and see if you can figure out the next sequence. All right, welcome back. Let's take a look at your table. So your table, you should have all 4 points. The zero term in this sequence is 16. The first term in the sequence is 4. The second term is 1. And the third term is 0.25 or 1/4. Because I look at my pattern and I went from 16 all the way down to 0.25 or 1/4 quickly, that's usually my indication that this is geometric, because if I'm adding or subtracting the same number, I can't make a jump from 16 to 0.25 that quickly. And the spacing between like 16 and 4 and 4 and 1 is not even. So that's how I know it was geometric. I can see that if I have 16 divided by 4, I get 4. 4 divided by 4 is 1, and 1 divided by 4 is 1/4 or 0.25. But remember, I don't want what we're dividing by, I want what we're multiplying by. So dividing by 4 is the same thing as multiplying by 1/4, which means this is geometric. The zero term is 16. My sequence generator is times 1/4. So that puts it into my geometric family, or that exponential family. So my equation is t to the n equals 16. That's my starting point. And then I'm multiplying by 1/4 over and over again. So I take 1/4, raise it to the n power. All right. Here's everybody's favorite way sequences can be written, and those are as word problems. It is the most challenging, okay? But again, if you don't like the way it's written, write it in a nice way. So this fourth question is actually why we have to wear masks, everybody, is because the flu and viruses, including the coronavirus, grow in that exponential. So I just kind of gave away which family it belongs to. But this is a rabbit problem. We have 3 students who come to school with the flu. They don't know it, but every hour after that, each infected student infects 4 other students. How many students have the flu at 9 a.m.? How many have it at 10 a.m.? So again, I'm a big table person because I like to be able to see my patterns. And I will tell you this, anytime you have a word problem, these are our real life problems, it always gives you the starting point, meaning it always gives you the zero term. 8 a.m. on Monday is the zero term, and that means we have 3 people at time 0. Okay, this is like patient 0. At time 0, we have 3 students that have the flu. So I'm going to mark those 3 students here. I'm going to draw my dots. That kind of represents the bunnies. Okay, but in an hour, what happens in 1 hour? Well, each of those students, notice it doesn't take a pair anymore. Every student infects 4 others. So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and in 1 hour, nobody's magically healed. All of these students now have the flu. So how many students do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15 students in 1 hour, which is 9, okay, have the flu. What would happen in the second hour? Okay, well, what are we always multiplying by? Anytime you're given rabbits or flu problems, this is going to be exponential. It's going to create that geometric sequence. So 3 times 5 gives me 15. Okay, so think about what would that 15 times 5 give you? That means by 10 o'clock, okay, this is 10 o'clock. If it helps you, I don't ever write out times because times are weird in tables. But if it helps you, you can write that out. I write it out in terms of time 0 in 1 hour and 2 hours. But if you want to write the time next to it, so that means at 10 o'clock, 75 students now have the flu. Okay, so clearly we know this is geometric. I gave that away at the very beginning. Hence why we wear the masks, okay? The zero term, we started with 3. The sequence generator is we're multiplying by 5. This means that our virus problems will always belong to our exponential, which means we have our starting point, which is 3. What we multiply, raised to that n power. Okay, pause the video here and see if you can figure out the last of these sequence problems. Okay. All right, good luck. Meet me back here to check your answer. All right, welcome back, Algebra 1. Hopefully you could see that this is going to be an arithmetic sequence. George at time 0, which is Sunday night, the beginning of the week, he gets $15 for lunch. And George is going all out this week. He's spending $5 every day for lunch. So what does he have at the end of Monday and Tuesday, meaning at the end of day 1, how much does he have? At the end of day 2, what does he have? Well, again, I see this in tables. So I set up my table. I see that at time 0, I have $15 to start with. And at day 1, I go to lunch and I spend my $5 at lunch. At the end of Monday, which is day 1, I'd only have $10 left. At the end of day 2, I have 5. And George better be careful because on Wednesday, he might not be eating lunch. I hope he has some good friends. Okay, my zero term, it's arithmetic because I'm subtracting 5. My zero term is 15. My sequence generators, I'm subtracting 5, which makes that story problem an arithmetic or a linear problem. And so we have T of n equals negative 5n plus 15. I know that this T of n and n is new for all of you, but don't worry, you're going to get lots of practice with it. And you're going to get very good at figuring out, is it exponential? Is it arithmetic? Is it T of n? Is it going to be y of x? All of that will come together with lots of practice. So make sure you're doing those review previews on your virtual days. And good luck on the exit ticket this week. You can use these notes to help you out. Have a great day, Algebra 1.